Number 7 says, a 5.6 gram bullet leaves the muzzle of a rifle with a speed of 320 meters per second. What force, assumed constant, is exerted on the bullet while it is traveling down the 0.75 meter long barrel of the rifle? It wants the answer in newtons. So here's what we have. We know the mass of 5.6 grams. Let me redo that. 5.6 grams. We know the final velocity is 320 meters per second. We also know the distance, or we could also call it the change of x. The change in the position of x is 0.75 meters. And that's all we have. We don't know the time, we don't know the force, and we don't know the acceleration. But what we want to know is force, so that we know one simple, really quick, easy equation for force. It's force equals mass times acceleration. And we know the mass, but we don't know the acceleration. So what's a formula we know for acceleration? Well, what is the definition of acceleration? The definition of acceleration is the change of velocity over time. When I mean change of velocity is the final velocity minus the initial velocity. So that's the change. We know that the initial velocity is 0. So the change of velocity is equal to the final velocity in this situation. So just know that this means the final velocity. So acceleration is the change of velocity over time. Well, we don't know time. So how are we going to figure that out? Well, there is a really simple formula for time. It's time equals, let me restart this. The initial velocity plus the final velocity, so that's divided by 2, so that's average velocity. Average velocity times time equals the change of x, or the change of displacement. And so we know that initial velocity is 0, final velocity is given to us right here, so final velocity over 2 equals time. Times time equals the change of x, and we can solve that for time, and we can say that the change of x divided by the final velocity over 2 equals time. So what do we have here? We're going to take this equation, what it equals t, so we're going to plug it in right here. And then we're going to take the resultant equation and plug it in right there, because it equals A. So what's that going to look like? Force equals mass times the change of velocity over, and instead of putting time, we're going to put the change of x over the final velocity over 2. Now we got to put down here, and we can just plug and chug. The caution is, whenever we have our force, our resultant force, newtons, comes from a mass in kilograms, which this is not in kilograms, it's in grams, and it comes from an acceleration in meters per second squared, which our change of x is put in terms of meters, and our final velocity, change in velocity, is put in meters per second. So that's fine. The thing that we need to convert dimensional analysis is our mass. So change the mass to kilograms before you start. 5.6 grams over 1 times 1 kilogram over 1,000 grams equals, and the grams will cancel each other out, equals 5.6 over 1,000 kilograms. That's equivalent to 0.0056 kilograms. And so now we can take our mass, 0 0.0056 times the change in velocity was 320 meters per second over the, and I didn't put change of x in here, over the distance divided by, so over 0.75 divided by the change of velocity, so 320 over 2. And I'm going to go ahead and work that out on my calculator. So 382.3 newtons is the answer I came up with. And you kind of want to do a little bit of thinking, does that make sense kind of stuff. So I asked myself, would 320 newtons of force pressing into a spot about that big, would that penetrate skin or bone or penetrate a piece of wood? The answer is I think it makes sense. Now this is a rough approximation, so there's I always try to think, does that make sense? So if I would have came up with something like 10 or 15 newtons, that would have been way off. And if I would have come up with something like 10,000 newtons, I would have thought probably I was a little bit over. So that's my range is huge on my logical thought process, but at least I know I'm inside of that range, so it makes logical sense.